In this video, we're just going to review integration by substitution and separable differential equations. So let's look at this first one. I think the first thing I might do with this is actually pull that 9 out, just like this, just have it be a constant multiplier out front. So then, I'm going to make u x squared plus 5. So du is 2x dx. And you can see I have an x dx, so I'm going to divide both sides by 2. So now I'll be able to replace this with a 1/2 du. So my integral will be, I'll still have the 9 out front, but then I'll have a 1 over u multiplied by 1/2 du. Bring that 1/2 out front, so now I have 9/2. The antiderivative of 1 over u is natural log, so I have 9/2 natural log of u plus c. And go back to where we started. So x squared plus 5. I guess I wouldn't really need absolute value here because x squared plus 5 will always be positive. But here we are. Okay. Next. This one, again, I think it's just as easy to take this 2 and just pull it right out front. So then I'm going to make u natural log of x. So du is 1 over x dx. Okay. And you look at this, and this integral then I can rewrite, still has the 2 up front, as 1 over u du. And that's it. You know, I can take out this whole denominator with the du, because it's like 1 over x dx. So the antiderivative is natural log, so it's natural log of u plus c. We go back to where we started, we end up with the natural log of the natural log of x. Just kind of an odd thing. Now notice please that that's not the natural log multiplied by natural. It's not natural log squared. It's the natural log of the natural log. Okay. All right, this last one, I think sometimes it's easier with trig functions to rewrite them like this with the powers. Maybe makes it a little more obvious what u has to be. So u is going to be sine. So du is going to be cosine x dx. So I can take out that whole thing right there with a du. So my integral becomes u squared du. And the antiderivative of u squared, of course, is 1/3 u cubed. See? Go back to where I started. Like that. Now, a separable differential equation, I just want to mention off to the side here that any differential equation that has something like this, like a what we're doing the derivative of a square, and that's a function of the square. Meaning the variable that you're trying to analyze the change is in some way reliant on what that value of that square was. You know, the change in y is somehow based on what the value of y is. So you can see that that's true here, that dy dx is equal to 2xy. So that, how y is changing is directly related to what the value of y is. Anything that is like this, you must separate. Okay, have to. So first thing, I'll multiply both sides by dx. Divide both sides by y. So I have 1 over y dy equals 2x dx. Integrate. So we separate, we integrate. The natural log of y is equal to x squared plus c. At this point, you could solve if you wanted to for the constant, or we could wait until the end. I'm going to wait till the end in this case. So I want to get rid of natural log. I'm going to take e to both sides. So e to the natural log of y is y. E to the x squared plus c. I can rewrite as e to the x squared multiplied by e to the c. Okay, because when you're adding exponents, that means you are multiplying their bases. And e to the c, e to a constant, this is a constant. So I could even rewrite further as y equals a constant multiplied by e to the x squared. So now let's solve for the constant. It says that y is 3 when x is 0. Well, e to the 0 is 1, so the constant is 3. So my final equation is y equals 3e to the x squared. Now, one thing I just want to point out here, and it's not magic, but it's always kind of cool, is if I was going to find the derivative of this, my derivative would be, 3e to the x squared, and then multiplied by the derivative of x squared, which is 2x. So my derivative, let me just write this, would be the original function multiplied by 2x. We'll go back up here. The derivative is the original function multiplied by 2x. Okay? Let's do one more separable differential equation. Okay? And again, you'll see that there's a y over there. It has to be separable. Don't let the variables fool you, though. Just, if it were a different variable, d square over d triangle, if there is a square in the differential equation, you have to do a separable differential equation. So dx, divide both sides by this. Okay. So we've separated. Now we integrate. The natural log of y plus 5 equals 1/2 x squared plus 2x plus c. Let's take e to both sides. A lot of e, a lot of that happens here. So we got y plus 5 equals e to the 1/2 x squared plus 2x. I'm going to multiply by e to the c again, like that, which means I'd have y plus 5 equals a constant times e to the 1/2 x squared plus 2x. Let's subtract 5 from both sides. And now it says that y is 1 when x is 0, so y is 1. So if x is 0, we get e to the 0, so it's just c minus 5. So c has to be 6. So my final equation, y equals 6e to the 1/2 x squared plus 2x minus 5.